we're going to talk about curve of best fit. And really, we've done this, okay? The things that you need to remember with your calculator, okay? And this is the first thing, one of the first things that you should do when you get your calculator, especially for the SOLs, okay? You need to turn your diagnostics on. So how do we do that? Go to our calculator. We go to second 0. Okay. And then you can either scroll down until you get to the letter D, which I don't recommend. Go to this. If you look, each of these buttons, starting with math, has a little letter with it in green. It's like a lime green. Yeah? Look for the lime green letter D. Yes. Hit that. Okay, takes you to, right?
Push the alpha button first, though.
No, don't push alpha. You don't need to because alpha is already pushed for you when you go to second 0.
Oh.
All right, so then now you're going to scroll down until you find diagnostic on. All right, so hit enter. And you need to make sure you hit enter again until you see the word done. Until you see done, well, it's not done, okay? All right, so make sure you have that. To enter in data, if they give you data, we would go to stat, edit. You would put them into X and Y, right? L1 and L2, list 1, list 2. To graph it, we have this, but you know what? We don't even need to graph it, to be honest with you, okay? We're going to check our regression, all right, our R. So in order to actually get the equation, we go back in the stat and we go to calc. And then we have each of these something regs, okay? So we could have a ln reg, a cubic reg, ln reg, which is the log reg, quad reg, quart reg, and exponential reg. All right? So now that you know so many more functions, you have some different options to choose from. Okay, so remember, what you are looking for is the value of the correlation coefficient, which is your R. Okay? You want the something reg that has the best R, okay? The strongest R. So basically what you're doing is you're always going to look at the last line.
You want it closest to 1?
Mm-hmm.
Or -1.
Uh-huh. Good. You're going to look at the last line to determine what the R or the R square value is. And the one that's closest to -1 or 1. That is the strongest correlation coefficient. Okay? And that's the one that you want. All right. I mean, there's a big, there's a big backstory to all of that, and it is pretty fascinating. We just don't have time to get into that. So, I'm just going to call it R, and that's what we're looking for, closest to -1 or 1. Okay? So, let's just kind of sketch a graph for ourselves so that we know kind of what we're looking for. Okay? If you're looking for a linear, all right, well, that's option 4, that's ln reg, right? This one, if you were to see a scatter plot or a graph of it, it would basically look like something like that, right? And then do it as a scatter plot.
You want us to draw that?
Is it just a bunch of random dots?
Yeah, you know what a scatter plot looks like, right? Yeah, it's just a whole bunch of, like, those are data points.
To make them do.
We're having fun. This is our. So if you look, then this looks like a line, right? It's not going to give you an exact, right? But that's the whole point of finding the curve or the line of best fit. You take all the data and you graph it, and we're going to find the equation of a line or a curve that best fits this. That's all it is. So you could have a positive, or you could have
This is fun.
Yeah. Listen, we're doing something different. Enjoy it.
I'd rather do
All
it
right.
in color.
Huh?
Are they all?
Well, when you see examples, they'll probably use scatter plots. Yeah. Because if they actually gave you the graph, then that one has an exact equation to it, you know. But best fit is you're finding an approximate. So quadrag, and you know what? Quadrag and quartrag, I want you to write it on the side. I think you guys have more room on the side here,
Hello.
right?
Mm.
These are called the powers. Okay. Yep. The quadrag and the quartrag, those are the powers. So they may refer to these as, you know, powers, functions.
Why?
I'll get back to you. I don't know. I don't know why they call it a different name,
There's
right?
something
Because a
different
cubic
than
reg is a power. All right. Quadrag. What does this look like? Think about it. Quadratic.
Square.
No.
Rectangle.
What?
a line.
A quadratic.
Rectangle.
It's a parabola.
Is it just
Rectangle. Happening. You guys like just.
this is not fun.
So if that's a positive one, well then we could have a negative.
I'm getting annoyed because I feel like I don't have enough dots in my area.
All right. I mean, you guys get the gist of it, right? We're trying to get the shapes. We're just using scatter plot. All right. We have a parabola opening up and a parabola opening down. All right. Let's look at cubic reg. Cubic reg is x to the third. And so, guys, x to the third means that the maximum number of turns that this can have is one less than the degree. So it's 2, right? You remember
Oh,
this?
Triangle.
No, it's the thingy.
You could have something like
Yeah, that thingy.
that.
Really?
Okay, this one has 2 turns. We could have one going the other way.
My pencil can't take this much glue.
I think for next year, maybe we'll provide like markers or something. Yeah.
Yeah, it's
Well, we
really.
can have an arts and crafts day.
This is
And you
just.
know what I'm going to do with this one is I'm actually going to kind of show you what this line would kind of look like. Okay?
No. Miss Osborne,
Mhm.
are you gonna go see Beauty and the Beast?
No, Mary.
You don't?
All right, so let's go back to court reg. Maybe it's all of those. You know what? Hold on. Let me double check on the powers. But court reg. If you have a quartic function, what is your degree? 4. What's the maximum number of turns?
3.
3.
Triangle.
So this
No.
one is the one that would probably look like this, like either a W or an M. And of course, they're never going to look this perfect. You know, I mean, this is a, you know, out in the real world type of thing. Alright. Alright, and you know, I'll draw this one too so that we kind of know. Alright, so EXP reg Well, that's an exponential, right? And that's basically everything that we're doing now, right? So you could have one that is a growth, right? You have one that's kind of going like that, right? One that's a growth. You could have one that's a decay.
Laugh at us.
And then let's look at ln reg, which is the log reg, right? So log can be maybe it looks like this. Right? Okay. And like this. So this is a general, it just kind of gives you an overview of where to start, like what kind of function you're looking for if you're provided with a scatter plot graph. Okay. All right, any questions?
Can we have a nap time?
All right, so number 1, determine the model that best fits the data. All right, so mine is actually just a little bit too, so I'm just shrink it down a little bit.
Yeah, I read your mind.
All right, so something like this. Which scatter plot is best modeled by a quadratic? I hear B,
I think it's B.
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 Anyone disagree?
It looks
No.
the most curved out of all of them.
Right? B,
Yay.
right? All right.
A.
So number 2, what type of function is best represented by the scatter plot?
A.
A, cubic.
Mm-hmm.
Do we agree?
Yeah.
Yeah, it is cubic. Right? 2 turns. I see 2 turns. Right? Easy. Okay. Which type of function best models the data in the scatter plot below?
C.
Exponential?
C.
C.
I think it's exponential.
So I'm hearing C and D.
C.
You know what? Not going to be exponential because you got this guy that's
just
curving up on the other side,
Okay.
right? Not going to be linear.
Why is it power?
That's the power. Because it's a quadratic.
Oh,
Is
it
it
just
the same?
didn't specifically have it. Okay.
Well, that's why I told you guys to write it down on the side there, right? For quadratic and the quartic. It could be either. That's why I was saying, I don't know. Like they like to use that name too. All right? Using SOL type problems to just prepare you guys for these. All right. So number 4, Diane put a set of data into her calculator, found the following, but based only on the correlation coefficient, okay, the correlation coefficient is R. Which of the regression functions would appear to be the best fit of the data?
P.
What did you say? Well, I mean, it doesn't really matter what their data was. You're just looking at R. We said the best R is the one that's closest to -1 or +1. Which one of those is closest to 1?
D.
D. That's it. That's what they're looking for. And what type of regression is this? What reg is this?
Isn't that linear?
Yeah,
Linear.
exponential reg because your x is in the exponent. So this is an exponential. Does that make sense?
Mm-hmm.
Yes.
All right. Great. All right, so some tips and tricks. They tell you what function the regression is. Just check that one. Okay? Sometimes they'll tell you, they'll say, what is the exponential model? Or what is the quadratic model? Right? So then just check those. Only check for the functions that are in the multiple choice answers. If in A, they give you a linear equation, B, they give you a cubic, C, they give you a quadratic, and D, they give you an exponential, why are you checking log? Right? Like you don't have to. Check only the ones that they give you the choices for. All right? Okay, so it says answer each question using regression. All right. So we have, it's way too big. All right. So the amount of lost revenue from tickets not sold for a concert is shown in the table. So, all right, they love doing things like this. How many rows do you have? You have 3, right? Do you need all 3?
Wait, what?
Do you need all 3?
No.
No. You only need the X and you only need the Y. Okay? So yes, the number of tickets not sold, sure, it might be helpful if we were doing something else with it. But in terms of this, which equation best models the relationship between Y and X, we don't need this. Okay? So don't let other information mess you up. So X and Y, which equation best models it? Okay, well then this is going to go into L1, this is going to go into L2. We actually have to put this into the calculator. But since we have multiple choice answers, let's check which regs we're going to be using. A and B, these are both exponential reg. Do you agree?
Mm-hmm.
And look at C and D. What kind of reg is that? Lin reg. So after we put this in, we're only going to check lin reg and exponential reg. Yes.
Does it matter which one like the L1,
Yes.
L2 doesn't matter?
Yes. L1 is always X. Okay. L2 is always Y. All right. So we have to go into stat, and we're going to click enter for edit. If you already have points in there, data points, go up to the top, hit clear, and hit enter, and it'll clear out everything. Here's something else. If you don't see L1 and L2, please say something. If it skips from L1 to L3, it will make a difference. All right? So make sure you have L1 and L2. So I want to put in points. Oh no. So make sure you put it in correctly.
What's the
The other thing is when you put in these points, you have to make sure that you have the same number in your L1 and your L2. Because if you don't, then you're going to get an error. Alright, so I can see I have 4 in my L1, 4 in my L2, all of my points are correct. I'm good. Yes? Okay, so the first one I'm going to check is exponential reg because A and B are both exponential equations. So I'm going to go back to stat. I'm going to tab over to calc, and I'm going to hit exponential reg, which is 0. Yeah. No. Okay, because there's no X or Y with it. It's just extra information. Yeah. Oh, look for whether they put X, Y. Okay? Alright. So when you hit 0 for exponential reg, you may see this. Just keep hitting enter until you get to calculate. Alright, what is my last line? I realize I have an R square and an R. You always want to look at your last one. So R for this guy. 0.99999. Really? That one's great. The only thing that'll beat this is a 1. Right? Okay. Yeah.
But you can tell if it's already that if you look through the numbers above it and you see those in the equation.
No, not always.
Not always?
No, I wouldn't trust that. Alright, so let's hit linreg. So stat, calc, linreg.
It's not a 1.
It's not a 1?
It's not a 1.
And doesn't beat that?
It doesn't.
It does not. If I look at my last line, my R is 0.97749.
0 to 1.
R equals 0.97749. Clearly, the winner is exponential reg, yes? All right, but here's the thing, though. That just tells me that C and D are out. But which one is it, A or B?
You look at the numbers.
Yeah, we got to go back and look at our numbers.
So this is where we can use my version?
No. So your calculator tells you the equation.
Yeah, that's what I meant. Like I was
So you
using.
meant in the data point.
No, I
Right.
used the equation to figure out which one was.
You should. Yeah, that's what we're doing, right? So when you go to get your line of best fit or curve of best fit, they always give you the standard equation first. So y equals a times b to the x. They give you a, they give you b, and your x and y stay the same. Yeah? So in this one is what, 997? So it has to be b. Alright? Questions? Yeah. Plug in 25 to here and see if you get that. You could. The only thing is that sometimes, say you choose the one where it doesn't come out exact, and then you cross it out, but it really, I mean, it could have been that one. Do you know what I mean? This is an equation of best fit. It's not going to be exact every single time. All right? Okay, so let's look at number 6. Sales of Gizmo 9000, blah, 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 computer company. X is the time in weeks. And Y is the number sold. X is L1, Y is L2. Using a what?
Exponential regression.
Exponential regression. Alright, about how many Gizmo 9000s will sell by week 7? Oh. This is a 2-part. You need to go and find the exponential regression equation, and then how many will sell? You have to find y. Week 7, that's the time. X equals 7. After you find your equation, you got to plug in 7 for x, and then tell me what you get for y. So if I do that, I need to go back in the stat. And I need to plug in my L1 and L2. No, they told you exponential, right? Okay. Exponential reg. I remember that one 0, right? I mean, you guys should be a lot faster at this than me. It's hard to do it up here with the smartboard. Alright. That's what I get on my screen. Do you have that?
Yes.
Okay. So here's my standard equation. Y equals A times B to the X. Well, for A, they give me 1093.09 times B is 1.49 to the X power.
Which is 7.
All right. Yeah, and this is the equation. Now we need to plug in 7 for X in order to find out how many gizmos will sell by week 7. And, you know, it's probably, it's good to round it to at least 2 decimal places, okay? 7 power. All right, so what I can do is I can store, right? Or it's just 1, so you can just, so what is this? 1093.09
Times 1.49.
0.49
To the 7th.
to the 7th power. Yeah? Hit enter. What do you get?
About 18,000.
17,822.
Is it okay if my number's a little bit different from yours, but I still get 18,000?
Well, I mean, that's fine. Your number is a little bit different if you rounded it differently.
I didn't add the .09.
Okay, so, all right, so you need to at least put decimals because it's not just a whole number, you know what I mean?
Okay.
Like, it's not just that number. You gotta put at least the decimals. But with these answer choices, I mean, 18,000. If you're anywhere near it, you know, that would make sense. All right? Questions about this? Good, Luis? All right. Okay, so which of the following equations best models the data in this table? And you know, they do emphasize best because it's not going to be an exact. All right? So let's see. I have an exponential. I have an exponential reg. What is this?
Lin.
Lin reg. What is this? Oh, H and J are both what?
Powers?
Quad
Oh,
reg. It's the quadratic, right? All right. So just test taking skills here, right? If I were just taking a test and I saw this, right? I wouldn't cross it out yet, but I would probably start with the quad regs, okay? Just because there are 2 of them, all right? Yeah. Just because there are 2 of them, maybe it's one of those. Like, that's the test taking strategy that I would take, all right? So I want to put all these into L1, put all those into L2, and then let's do a quad reg test. All right, so I put everything into the calculator. I'm going to start with quad reg. Okay, so quad reg, I have, what is this, 0.48, negative 1.02, and 1. My R squared, my correlation coefficient for the quads is 0.9898. All right. So R squared, 0.9898. And it's not H, right? Because H doesn't have a B. H doesn't have a B term. So we can check lin reg and exponential reg because maybe one of those is 0.999 or 0.1, right? So And 0.48, that's so close to 0.5. That's why I'm okay with the 1/2 x squared. But let's try it anyway. Linreg. Negative 0.548 for Linreg. That's no good, right? What's the other one? Exponential. Negative 0.40. That's no good, right? So your answer has to be J. Does that make sense? Any questions? All right. So the next one. The table shows the height of a ball as it is thrown, and travels across a horizontal distance. Okay. So use your calculator to find a what model?
Quadratic.
Quadratic. So this is a quad reg. To represent the path of the ball and round to how many decimals?
3.
3. All right, so they give you L1, they give you L2. All right, so the model of best fit here for your quad, you should have y equals negative 0.004 x squared plus 0.352x plus 0.369. Yes? Good. So find the height, which is y, if the distance is 83 meters. So x equals 83 meters. You should have, thank you, meters. 2.029 meters. Yes?
Is it okay if we just put 2?
It's not just 2. Go back and check your data.
I know, but is it okay if we just put 2?
So round to 3 decimal places.
Hey, can we just put 2.0? 2.
3 decimal places!
Okay!
Yes.
My grades.
We'll try it again. Okay. You gotta put parentheses around it. Yeah, just do it all over. If your equation is right, just plug it in and just put 83. Put it in parentheses. Number 9. All right. Think about your strategy for number 9. You have L1 and you have L2. A is asking you, is this model linear, quadratic, logarithmic, or cubic? So you have 4 different regs that you need to test out. Look at that R, or the R squared, and see which one is the best. Okay? So let's do that.
So we do 6.
So when you do
0.099
linreg,
plus 6.108,
you get negative point, what is that, 4307? Or is that 9307?
What?
For linreg.
0.9307.
9307. For quad reg,
0.9925.
you get 0.9925.
Log is the error.
Yep. Log, which is ln reg, you get error, so that one is out. Right? And then cubic
0.9999.
is 0.9999. So the winner here is cubic. Yeah. And then what is the model for this data? So cubic has A, B, C, and D. Just make sure you go and get those. Let's round it to 2 decimal places. So we have negative 0.69. right, so any questions about this? Yeah.
I have a question.
So this next one, so the data below shows the height of a weeping cherry tree planted in Washington, D.C. in 2000. All right, so it says determine a log regression model. So we're using the LN reg. All right, it says let x equal 0 represent the number of years since the year 2000. So basically, guys, so rule of thumb, okay, if you see years, right, don't put in the actual years into your L1, okay? Start with 0 or start with 1, all right? Most times it's gonna be 0. Here they tell you is 0, so start with that, okay? And then it says then determine the height of the tree in 2015. Well, then we're gonna find out what. So 2015. Let's do this first. 2000 equals 0. So 2001 equals
One.
what? 1.
This is 1 through 11.
And that would be 2, 3,
2,
4,
5,
5, 6, 7.
And then 1.
Yep. And what you're trying to find is the height of the tree in 2015. Well, then that's really what?
15.
15. Because it's 2015 minus 2000, which is 15. Okay, that's what you're going to plug in after you find your ln reg equation, right? Model. All right, so now we're going to put this into L1, 1 through 11. If you are getting an error doing this, then let me know, okay? And please make sure that your L's are L1 and L2, all right? You have to hit clear, don't hit delete. Don't delete the whole row. Jaden, did that get fixed? All right. Oh no, we have a minute. Make sure you guys do your homework and keep doing this. But you guys feel pretty comfortable with this, right?
No. Yes.
I like this.
Alright.
What is 22 point, yep, 60, I 65 because it's rounded, but yeah. 22.65 feet. And your equation was this one. Okay? Good. Do your homework.
Miss Osborne.
Yeah.
That tree today